Hello, welcome to another tutorial. In this video, we are going to design a reinforced concrete frame according to BS8110. Let's get started. After opening the RSA, click the New button, then select the Frame 3D Design template. We will start with some project setup. Click the Tools button, then the Preference button to select Great Britain for regional settings, English for working language, and English for printout language, then click Accept. Next, click the Job Preferences button and make sure the design codes on the left is selected. For steel/aluminum structures, select BS5950-2000, and for RC structure, select BS8110. Next, expand the design codes and choose loads, and then select BS8110 for codes combination. Once you've done that, press OK. Press Yes for that pop-up message. Now, we are going to start by laying out some project axes to draw a structure. Click the Axis Definition button from the Modeling toolbar, then on the X tab, enter 0.00 for the position, then 1 for number of repeat, and 4 for distance, then press Add. Now switch to the Y tab and do the same except choose A, B, C for numbering. Next, switch to the Z tab and do the same except put 3 for distance, and choose value for numbering, and then click Apply and close. Now we will move into laying out beams and columns for our model. Click the Bars button, and once the Bars dialog box is open, select RC column for bar type. Then click the three dots next to the section to open the new section dialog box and put 230 mm for both width B and height H, and C25 for materials, then press Add, then close. Next, click to place columns at grid intersections shown on your screen. Now select RC beam for the bar type. Then click the three dots next to section to open a new section dialog box. Then select C25 for materials, put 230 mm for width B and 300 mm for height H, and then press Add, then close. Next, click to place beams at grid intersections shown on your screen, then close the bar dialog box. Now, press the View button and select the 3D Projection XYZ button to orient the projectee view to 3D. Next, we are going to select all elements, then start the copy command from the Edit menu, then Edit, then Movie/Copy. Make sure Copy is selected and enter 1 for number of repetitions, then move into the model and click 2A and then 2B to copy, then close. Press the bar button to open the bar dialog box. Make sure BR 230 by 300 is selected. Then click to place beams at grid intersections shown on your screen, then close the bar dialog box. Now we will set up our stories to match the level we have added from the Geometry menu, then Stories, then Stories. Select Define manually, then enter 1 for number of repeats and 3 for height, then press Add, then close. Your model should have story 1 instead of +3. Now we will set boundary conditions. To do this, we will open the Supports dialog box by pressing the Support button. Select the fixed support, which is fixed in all directions. Then click on the bottom of every column to place it. Now let's put cladding to our model. We will not design a slab in this tutorial, so we will use cladding as a replacement for the slab so that we can transfer loads from the slab to beams without designing a slab. That's the purpose of cladding. From the Geometry menu, select Claddings. Make sure load distribution is two-way, then select Rectangle, then click the following intersections to define the 3 points of rectangular cladding, then close. You can press the Section Shape button to see the 3D view of beams and columns. Now let's create some load cases. Press the Load Types button to open the Load Type dialog. Let's start with the dead load. Press Add to add the dead load DL1, then change nature to live to add the live load LL1, then close. Now right-click on the display, then select Table, then select Loads. As you can see, the self-weight of all elements have already been defined. Now select the DL1 from the load case selector, then press the Load Definition button to open the Load Definition dialog. Select the Surface tab and click Uniform Planar Load to open the Uniform Planar Load dialog. Enter -6 for the Z value and press Add. Then click on any point of the cladding to apply. Now, select the 2LL1 from the Load Case selector, then click the Uniform Planar Load to open the Uniform Planar Load dialog. Enter -11 for the Z value and press Add. Then click on any point of the cladding to apply, then close. Let's turn off the structure axis to have a clear view of our model by pressing the Axis Definition button. Then on the Structure Axis dialog, press the Axis Manager tab, then turn off the structure axis, then press OK, then close. Now we want to generate load combinations to use in an analysis. Open the Loads menu, then Automatic Combinations. Select the Manual Combinations Generate, then press More. Press the Next button to be taken to the list of combinations that robot plans to create for us. Select the ULS1 and the SLS1. ULS is ultimate limit state and SLS is a serviceability limit state. And then press Generate. Now take a look at your Analysis Types dialog and you will see your newly added load combinations. Now let's run calculation by pressing the Calculations button. As you can see, we have 0 errors or warnings. Now it's time to look at results for bars. From the Results menu, select the diagram for bars. Now go to the Parameters tab and select the field, Differentiated, and Labels, then press Apply. Now go to the NTN tab and select FX Force, then Apply to view the actual force diagrams. You can select MY moment to view the bending moment diagrams as well. Next, we will take a quick look at the results table for reactions forces by pressing the table button, then selecting reactions, then OK. Results are arranged by node/case in the first column. You can select the specific load case or load combination to view its results. Let's select a 1DL1 to view its results. Then let's select 2LL1. And now let's select 3ULS1 to view its results. And we can also select the 4SLS1 to view its results as well. We can view the results of all load cases and combinations by pressing the Select Case button, then pressing the All tab, then Close. Now press the Envelope tab to see the maximum and the minimum of every reaction force for each node, as you can see on your screen. Press the Global Extremes to see the maximum and minimum of each reaction force and their corresponding nodes and load case or load combination. For example, the force Fx is maximum at node 5 and load combination 3C, which represent 3ULS1. You can see the results of other parameters, which are bar deflections, nodal displacement, and force by yourself. Now let's start the designing part. We will start by designing beams and then columns. Let's select all beams by pressing the Bar Selection tab, then select BR 230 by 300, then press the double arrow, then close. As you can see here, all beams have been selected. Now press the provided reinforcement of RC element button to start designing. These are the load combinations we are going to use. Press OK to continue. As you can see here, the general parameters of the beam cross-section have been already updated according to our model. We can move this window down here to see the beam model. I'm sorry for this inconvenience. My laptop is acting up, but all is well. Click inside the window, then press the zoom all button to view our beam's geometry. Now press the calculation options button to open the calculation options dialog. Let's start with the general tab. For the cover, put 30 mm and select fixed for bottom, side and top. Put tick for correction of cracking by increasing the reinforcement area. But we won't select the deflection calculations since the BS8110 considers the calculation of span over effective depth threshold for the deflection check. We won't consider seismic analysis for this project. And for geometry optimization, we will select the height h to be fixed and the width b to be fixed as well. Now let's move to the concrete tab. And we won't change anything here. Press the longitudinal reinforcement tab and then select the grade B500A, B or C, then deselect the H6 since that size is rarely used in construction. Now let's do the same for both transversal reinforcement and the additional reinforcements. After that, save those settings as T1 so that we don't have to repeat this process again. After that, press OK. Now let's move to the reinforcement pattern. Let's start with the General tab. For the reinforcement segment, select the whole beam. For compound structure is yes by default. For straight bars, we can leave the defaults, and for the remaining settings can be left unchanged. Now, let's move to the bottom reinforcement tab. For the number of layers, select 1 and also select auto. For diameter, don't put anything. And for the reinforcement column number, select auto and put 2 for N max. For the top reinforcement tab, select as bottom reinforcement. Now press the transverse reinforcement tab, and for arrangement type, select the fit to the envelope. Then you can leave other settings unchanged, but we need to deselect this one. Press the construction reinforcement tab and select to consider in load capacity calculations, and for diameter, select as for main bars. You can leave other settings unchanged. On the shapes tab, we don't change anything. Now let's save those settings as T1 so that we don't have to do it all over again. After that, press OK. Now let's start calculations. After calculation, press the beam diagrams tab to view the bending moment diagram and shear force diagram. We will discuss them later. Now let's move to the beam reinforcement tab to see how reinforcements have been arranged along the beam. Click on the main view window and then press the zoom all button to see the beam and its reinforcement details. Do the same for the secondary view window on the left side. Now you can select different reinforcement types to see where they are in the beam diagram. These are the main top reinforcements, which is there due to the presence of negative moments at beam column connections. Their diameter is 12 mm. These are the main bottom reinforcements and their diameter is 20 mm. These are assembly top reinforcements and have the same diameter as the main top reinforcements. And these are transverse main reinforcements or stirrups with a diameter of 8 mm. You can press these tabs by yourself to see more details about the reinforcements provided. Now press the beam note to view calculation notes. These are internal forces diagram, where the red color is the capacity of the beam and the green color is the design values after the redistribution of reinforcements. The red line needs to be more than the green line so that the beam can withstand the design load. The last part is the material survey, where you can use this information to prepare the bill of quantity BOQ. Now, let's return to the beam reinforcement tab, then press the drawings button to view the drawing details of the reinforcements. As you can see, this is a drawing detail for beam 8. Expand story 1 and you can see that the beam 8 has been already designed. Now press beam 7 and on calculation options, select T1 then OK. Now press the reinforcement button and select the T1 then OK. After that, run calculations. After calculations, you can see that the results of beam 7 are the same as that of beam 8 since they are identical. Now let's move to the beam 6 and repeat the same procedures. And now let's design beam 3 by following the same procedures. Now we are done with the beams. Press the structure tab and on the layout select start. This select the beam by left click on the screen, then pressing the bar selection button to select all columns. After that, press the provided reinforcement of RC elements tab to start designing columns. Don't change anything here. Then press OK to proceed. On the RC component inspector, the new added RC element is labeled column 1-5. This means that those 4 columns are identical and we only need to design one column and duplicate the results obtained in other columns. You can view the number of columns from the structure tab by turning on the bar numbers. These are those columns represented by column 1-2 5. Now let's return to the column view tab and press the calculation options button. For a cover, select a fixed value of 30 mm or more. For reinforcement optimization level, select high and don't select the design unidirectional bending. Now press the concrete tab, then don't change anything. On longitudinal reinforcement, select the B500 A, B or C for grade and then deselect the H6. Do the same for the transversal reinforcement, then save those settings as T1, then press OK. Now let's move to the reinforcement patterns. Press the longitudinal bars tab and on corner bars select auto for diameter and the one for maximum number of bars in a bundle. On intermediate bars select identical diameters and the one for maximum number of bars in a bundle. On constructional bars, don't change anything. Now let's move to the transversal bars and leave everything unchanged except select the first section. On the door bars tab, select auto for bent bars and don't change anything on the shapes tab. Save those settings as T1 then press OK. After that, run calculation. Then press the column reinforcement tab to view results. Zoom the display window by using the zoom all button, then click on the reinforcement to see its details. Now press the column note button to view calculation notes, and as usual, at the end of notes there is a material survey. Press the column results to view the results of each scenario and their safety factors. Return to the column reinforcement and press the column drawings button to view the detailed drawings of reinforcements. Now let's save detailed drawings of the RC column by right-clicking the drawing display and selecting the final printout format. After that, press the printout button. Select Microsoft Print to PDF for the name, and for print range select all, then press OK. Let me save this drawing T1 on the desktop. Now let me open it. As you can see, the drawings look just fine on PDF. Now let's see how we can save calculation notes. Remove the drawings window, then press the column note tab. These are the column notes we are about to save in a Word document. Click the results menu, then calculation notes. Select what you want, then press OK. These are the calculation notes. Now, click the File menu, then Save As. You can choose any format you want. I hope you've learned something from this tutorial. Until next time, goodbye for now.